Systems of linear inequalities. A linear function has the equation y equals mx plus b where m represents the slope, and I hope you remember that that is rise divided by run, because that'll come up later. And b represents the y-intercept. So it's basically 0b, right? In fact, I can guarantee you that in grade 12, that last constant is always going to be your y-intercept. So you're going to do cubic functions. Doesn't matter. That last, the loner at the end tells you what the y-intercept is. Okay. The only one that I'm going to warn you is if you have that bracket, the descriptive form. A lot of students think then that, oh, that one is alone. That's my y-intercept. No, you have to recognize that that is the descriptive form. Okay. So if you have any brackets or anything in between, then that is null and void. That doesn't apply. Okay. 4 types of slopes, and I think some of this might be reviewed from the beginning of the year even, like when we started this course. So you have 4 main types of slopes. So I'm going to kind of quarter it. So I'm going to take this and kind of split my page in half, and then I'm going to half those halves to get the quarter. I'm just going to have those 4 slopes. All right. So you have your 4 t charts. So it's y and x, y and x, y and x. So in no particular order, right? But we're going to have one that goes like this, one that decreases, so we will say that, right, this will be a positive, right? This will be a negative slope. If you didn't leave enough space, then just do it underneath here, right? This would be a 0 slope. and this would be undefined. Okay, positive 0, undefined. So it's a vertical, right? Vertical is undefined, and so forth. The equation of a positive would then be y is equal to mx plus b. The equation of a negative would be negative mx plus b. The equation of a line with a 0 slope is y is equal to a number. The equation of an undefined would be x is equal to a number. Okay, so if you have just y and a number, you know it's going to be a horizontal line. If you have x is equal to a number, you know it's going to be a vertical, right? And this number is where it's going to go through, right? So this x-intercept in this case would be number 0, right? So that is the number there. It will tell you where it crosses, okay? On the other hand here, this would be your y-intercept, that would be 0 number, okay? So this is really just going to tell you where it's going to cross on the y-axis, right? No, if it's y equals to 0, then obviously it's right along the x-axis, okay? I will also add something that to prepare you for grade 12. A positive slope always goes from quadrant, this is 1, 2, 3. It always goes from quadrant 3 to quadrant 1. Always. You always end up, you always are going to start in quadrant 3, somewhere in quadrant 3, and end up in quadrant 1. Always. That's like the general behavior of a positive. A negative, you're always going to be quadrant 2 to quadrant 4. Okay, so 2, 4 is connected. And then this one obviously will depend, right? It will be quadrant 2 to 1 or 3 to 4. I'm not going to write that down. This one will be from 4 to 1 or from 3 to 2. Okay, so I'm not going to write that down. As long as you remember these two here, you will be fine. Okay. Park it there for a bit. Let me know if it's going a little too fast at home, okay? So intercepts. Okay. So just so you, I never assume that we know this, okay? So if this is your line, right, you have a y-intercept here, and you have an x-intercept here. Okay, so just so you know what we're talking about. To find the x-intercept, let y equal to 0. So you're going to find x0, right? To find the y-intercept, let x equal to 0. So it's going to be 0y. A constant linear equation, y equals to 4, is a horizontal line going through 0, 4. A vertical line with equation. These are just examples, right? Equation x equal to -2. Goes through -2, 0. And these two, for some reason, students mix up, right? Like they'll sometimes graph a y equals 4, they'll graph a vertical line going through 4. If you forget, right, like just if it's y equals, try to type that into your calculator, y equals 4, it's going to be a horizontal line going through 4, right? Like if you forget. And the x equals to something, right? I tell you up here on the graph and here again that that's what you need to watch out for, okay? Okay. I'm getting my cue here from the class, so if I see that they're still writing, I'm gonna slow a bit. Okay. Find the x and the y-intercepts, rearrange, then graph each of the following. Oops. Sorry, I need to back. We're gonna make B, we're gonna change this to a 5. Sorry, this was supposed to be a 5, not this. Can you change that, please? So this is 5x minus 2y is equal to 28. And then it's 3x minus 2y minus 6 is equal to 0. There it is. And then d 4x plus 4y minus 16 is equal to 0. Okay, so your goal is I'm going to do the first one with you. But every time you see something like D, for example, brackets and whatnot, you want to clean it up a little bit and see if you find something unique about each one of them. Like you could end up with just an X or just a Y when you're cleaning it up. When that happens, you need to remember, because most of us are going to have an X and a Y in them right till the end. So you know it's going to be a slanted line, either going up or down. But if you notice that you end up with just this, one of these two, those are unique and they're just, right, this would be a vertical line, this would be a horizontal line, which will also be thrown in the mix, okay? So just watch out for that. Don't think it's always going to be the same. I just focus on these ones because they're a bit more challenging perhaps, okay? So let's do A together. And the reason why I'm getting you to do this is because that's going to be very important for you to do and to know how to do when we have many lines being graphed at the same time. So here we go. Find the x and the y-intercept. So this is how I do it. So I will copy the equation again just so we have it. And to find the x-intercept and the y-intercept, I always do them side by side like that, and I make a t-chart, right? Under the x-intercept, we let y equal to 0. And for the y-intercept, we let x equal to 0. This is just a little reminder. Okay? So you take this and you say 5x plus 10 times 0, and this I will just do the first time here, is equal to 20. So you take that equation, you just plug in a 0 for y, you know this whole thing turns into 0. So 5x is equal to 20, divide both sides by 5, x is equal to 4, so we know that it's 4, 0 that we're after. Okay, so we found our x-intercept there. And the y-intercept we will do on the other side. Okay, so we let x is equal to 0. So 5 times 0 plus 10y is equal to 20. And these aren't always pretty numbers, by the way. So the 5 times 0 just turns into 0. So it's 10y is equal to 20. You divide both sides by 10. Y is equal to 2. So 0, 2 is the other point that we're after. And then I box this whole thing in so that it's kind of like packed away. Okay, this is what we're gonna need. We're gonna need these two to come up. So we found the x-intercepts. These are the two that I need to graph. Okay, for you to graph it quickly, if you find the intercepts, is the best way to do it. Here we're gonna rearrange. What I mean by that is make it look like, right? That's what I mean by that. And why are we doing that? Because we're going to use our calculator at some point. We're going to have to enter this equation into our y1 or y2 or whatever the case may be. So we take 5x plus 10y is equal to 20. You bring the 5x over, that's 10y is equal to negative 5x plus 20. Divide both sides by 10. Y is equal to negative 5 over 10 x plus 2. We can reduce our fraction even though we don't need to. When it's that obvious, I'd like you to do it, but don't bother simplifying fractions because some students try it and they get it wrong and then everything goes out of whack, right? Like the points that we're going to find later on are all off because they didn't simplify correctly. So rearrange, there it is. So we found the intercepts, we rearranged it. Now it's also asking us to graph. Okay, and we're going to graph this by hand. Our ruler is an asset right now. Okay, so you Should be able to do that for ACs and whatnot. You need to be able to come up with your own grid. On a test, I will provide you with one, but you'll need it for everything else. And then it's basically back to quadratic, right? Like you label your axes, right? And now there's no word problem, so it's just X and Y. Okay. You need an appropriate scale. I look at my intercepts to guide me, 4, 0, and 0, 2. So basically, if I just go out by 1 in each direction, I'll have plenty of room. So I'm going to go 1, just space them out equally, okay? And I really like your graphs for the most part, right? So 1, I'm just going to label every other one like that. And I'm going to go up 1, 2, 3. You don't need to, right? This one I can label individually. Why not? As long as the scale is consistent, I don't really mind. And then you go back 1, 2, 3, 4, 5. You don't need to go that far back, right? But you're kind of making a little grid. And so what I mean by consistency, right? You can't say 2, 4, 6, and all of a sudden here you're going 1, 2, 3, right? It has to be consistent. The spacing has to be consistent. So some of you, on the test, you decided to go up by 120. You were consistent going up by 120. Perfect, right? So let's do this. 4, 0 is right here. 0, 2 is right there. You've graphed it. It's all you need to graph this line. And then we go y is equal to -1/2 x plus 2. You decide which equation you want. Do you want the rewritten, or do you want the original one, right? The standard form. All components are still there. It's not a word problem, so we include all 4 quadrants. If it's a word problem, we're going to be in quadrant 1, right? And this is going to be representing something, and this will represent something as well, right? Could be money and something else. So this right here kind of sums up is like a critical basic skill you need to have in this unit to do well. Okay. What else should I say? Yes, always be critical of your graph. Okay, don't just look at this and graph it and be done with it. Does this line make sense? When I rearrange it, I got a negative slope. A negative slope means that it's gonna go down from left to right. It's decreasing, so it does. This matches the graph, and so do these points, right? Because if this line had been going up, you could have made a mistake here, an arithmetic mistake. You probably dropped a negative somewhere, or something happened, and you got it wrong, right? So you got to be. They kind of have to jive. Okay, they have to. It's like a check, verify there. So be careful. Sometimes y, like let's say here, back up to this point here, and I'm just giving you an example. If you had a -10y here, you would have to divide both sides by -10, and that would give you a negative here and here, okay? So be very careful with your signs. Same here. If you're dividing everything by -10, right, it will change this sign and it will change that sign as well, right? Don't forget to divide the constant by this. I see that all too often. You put down -5/10 and then plus 20. Like students forget to divide both of these terms by that number. So those are mistakes that happen quite often. So I like to highlight them so you kind of remember how to do that. Okay, so we're gonna spend some time. I'm going to get you to do B to D, right? From B to D, try those on your own right now. Give you some class time to do that. And basically, you're doing what I just did here. and then we'll reconvene in a couple minutes, 10-15 minutes or so. So 3 o'clock, let's say. Okay, so remember, this is B for you, so keep it like that. Okay, don't change it. I just went off track here, off script. So let's see. To find the x and y intercept, notice that I just don't bother to write this part down anymore in my work because this turns into a 0 here. Okay, so just basically you're left with 5x and equals to 28. And then I divide both sides by 5, which gives me 5.6. And so I state it like that. And the y-intercept, the 5x part is gone because that's where you insert the 0. So you're left with negative 2y is equal to 28. You divide both of them by negative 2. You get negative 14. So that's your y-intercept there. I rewrite it on the side here. I basically, my first line right away shows that I bring over the 5x subtracting. Then I divide both sides by negative 2. And that turns the 5 and the 2, they're both negative. So that turns into a positive. And then 28 divided by negative 2 is negative 14. So this is the rearranged version of your equation, right? That's the slope-intercept form. Don't worry about this one here just yet. But if you graph it, right, I had to adjust my scale, right? So I went down by 5s to make room. If you use more space, that's fine. And here I just used a scale of 1. So the 5.6 goes right about there. And the negative 14 goes right about there. And then you draw your line like that. And you label. I guess I forgot to say, I will be okay with you not labeling if you have the work done somewhere on that page, right? But if that work doesn't show up anywhere, then I would expect you to label it on the graph, okay? And so this is B, right? And now your C looks like this. Okay, so the x-intercept, watch what happens. I turn that 2y is gone because the 0 gets plugged in there. So you're left with 3x minus 6 right here is equal to 0. You bring the 6 over, you divide both sides by 3, you get 2, 0. Y-intercept, you let the x equal to 0. So basically that first term is gone. You're left with negative 2y minus 6 equal to 0. Bring the 6 over, divide both sides by negative 2, you get negative 3. 0, negative 3, that is. Rearranged, I bring the 3x over right away, and it goes negative. Then I divide both sides by negative 2, turning the this slope into a positive. 6 divided by negative 2 is negative 3. And then here, you graph it, right? So x, y, I use a scale of 1 going each way because it's just convenient that way. And I also put the equation down, right? So equation, scale, label your axes, right? Soon it will change. It will not be x and y. And I don't know why I did this, but I must have explained last time around. If you want a third point, right? Like let's say you want to find a third point, you could make x equal to 1, for example, and find out what y is using the original equation, this one right here, right? So you would just go, what's y? So plug in 1 for x and then basically solve for y and you find another point. not terribly crucial, but it is important to remember that. D, here it is. So you got to distribute, right? 4 times x is x, 4 times 4y is 16y. You get rid of the brackets, you get negative 16 there. I leave it like that. To find the x-intercept, you drop the 16y because it's turning 0, so you're left with everything else. You get 4, 0 there. To get the y-intercept, you get rid of the 4x, so it's a 16y minus 16. Bring the 16 over, divide everything by 16, you get 1. So it's 0, 1. Rewriting it, right? You bring the 4x over, right? The 4x used to be here. It comes over negative. Divide both sides by 16. You get negative 4 over 16 plus 1, right? And that negative 4 over 16 can be further reduced to 1 over 4. And there it is, okay? And the graph of this is up here. So we are expecting a decreasing line because it's a negative slope, and so it does pan out, it does work out, and that's exactly what we want. Any questions? We're good? Yeah.
Let's say for a test, do we have, if we like, is it required for us to simplify that
This,
one?
no. No, I will not ask you to simplify a fraction because like it's not the point. The point will be to find like the point where they intersect and stuff like that. So I'd rather you not, if you're not sure, because that, as I said, it throws, even if you're off by a little bit, everything else will be off, right? So just leave it. And another thing I'm going to tell you is some students like to turn that into a decimal and then they drop decimals. They just use 2. When they enter that into the calculator, it is also slightly off. Your answer is slightly off from mine. So I just say, unless it's a finite decimal, like 0.25 or something like that, or 0.75, just leave it as a fraction when you enter it. And I'll show you how to do that, and we've done it. So it's nothing new. So good question. Okay. So what are we at? 309. Yep. We're gonna keep going here. Graphing systems. So now we're going to do more than one. Okay. Graphing systems, 2 or more lines. Okay. Coordinate or coordinates of the point of intersection. And this is a word that we're gonna, these point of intersection is an important term. That's where the things meet. The point of intersections. The Steps for graphing systems. And these are just a suggestion. I won't say you have to, but overall, you'll be better off if you do. Do the T-chart thing for the intercepts. Rearrange. All equations. You will enter these into calculator. Okay, that's why I'm asking you to do that. Graph all equations same grid, comma, using the intercepts found in first step, right? Use the intercepts to determine the scale. Okay. Fourth, find all points of intersections. They are also known as corner points. Some worksheets call them corner points, okay? So points of intersections and corner points, we basically mean the same thing. Using calculator. So the points of intersections, those you use your calculator for, don't do it by hand like you would have done in IAPR. So let's try that right away. And I will write them, graph the following systems. So I'm putting them like side by side so that we can do the work like kind of in columns. That's why I do that. And I most likely will do that on a test or AC. I'll put them like this so that you can start right away. But in IPR, you probably had them like stacked like this, one over the other, and then you did the work on the side. It's okay. They're both saying the same thing, right? Okay, so as before, step one is find all the intercepts. So I'm going to find the intercepts for each one of them, okay? And after a while, you will be pretty good at it, okay? So x-intercept, the y is gone, right? So it's 5x is equal to 28. Divide both by 5. X is equal to 5.6. 5.60 is our x-intercept. And on the other side, it's 4y is equal to 28. Divide both sides by 4. And y is equal to 7, so it's 0, 7. Done. I found the intercepts for both. I'm going to rewrite it down here. 4y is equal to negative 5x plus 28. Okay, so I brought the 5x over, changing signs. Divide everything by 4. Y is equal to negative 5 over 4x plus 7. I will kind of just break this here. This has brackets, clean it up. That's what brackets are basically asking you to do, clean it up, right? Like expand it. So we're going to clean it up first, right? So y minus 12 is equal to negative 4x minus 8. And you can leave it like this, or actually go ahead and rewrite it already. It's up to you. But at this point, I will do this. Once I got rid of the brackets, I can do this. And so for the x-intercept, the y is equal to 0, right? So it's negative 12 equal to negative 4x plus minus 8. You will add 8 to both sides, leaving you with negative 4 is equal to negative 4x. And we're not used to the variable being on the right-hand side, right? That's okay. X is equal to 1, so 1, 0 is our x-intercept. For y-intercept, x is equal to 0, so it's y minus 12 is equal to negative 8. You add 12 to both sides. Y is equal to 4, so it's 0, 4. Rewriting it down here, all you have to do really is bring the negative 12 over. So I'm going to show you that that's what's happening. And then it's negative 4x plus 4, which I expect, right? I expect my y-intercept to be 4. So just make sure it pans out there. Cutting it there. X equal to 3. Oh, I recognize something. Vertical line goes through 3, 0, right? So you can't really do anything with it. That's it. Like you're ready to graph that, right? We know where it goes through. Nothing out of the ordinary there. Okay. So let's attempt to graph this now. So I will already do my grid, okay? So I will start that off on a different page here. And so you have to guide, you have to let the intercepts guide your scale. Okay, so for my x, for example, the x value, the greatest is like closer to 6, right? There's 5.6, 1, and 3. So if I go out to 6, then I'm fine. The y-intercept is 7, 4, right? So 7 and 4. So I'm going to go up to like 8 or 10. We'll see, right? In fact, you might just say, okay, forget everything. I'm just going to go out 10, 10, 10 each direction and just make sure I have enough space, right? So here we go. I think that's what I'm going to do. I'm going to go 2, 4, 6, 8, 10. Okay, so 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. X and Y. It would be appropriate probably to do the same thing with the other side. At -2, -4, that's good enough. So the first line, that's another thing. Keep the lines together, right? 5.6, this would be 5 right about here. So just over 5.5. So 5.6 is right about there. 0.7 is right about there. It's between 6 and 8, right? And then graph your line right away so you don't forget those two go together, okay? In fact, I'm going to go ahead and already write down my equation at the end. Put them at the end. Don't put it somewhere in the middle because you might cross it out with another line. But I would do that right away. So you know this is the equation that goes with it. And then 1, 0 and 0, 4 is the other one. And you cross it like this. And don't be scared to extend, okay? Extend your lines. There's that. And then the other one is a vertical line going through 3 here. Now, before we go, I'm not going to show you how to do it with a calculator today because I need a little bit more time. But let's just go and find our points of intersection. Where do two lines meet, right? There's one right here. And students sometimes pick the crossing the x-axis, right? No, that's not. This is the other point of intersection here. And this is the point of intersection. So there's 3. So I'm going to make a little thing here. These are POIs, okay, or corner points. And we will find them tomorrow using our calculator, okay? I would like you to try to graph, like go all the way to this point right here. That's your homework, okay? I will give you 3 questions to try. And remember, this is all on video, so if the notes, you didn't finish the notes, it'll be up there in a bit. So write these down, okay, before you log off. And once you did so, you can log off at home. See you tomorrow.